Good morning, everyone. Welcome back with another episode or another class about phenol. Today, we are going to discuss the chemical reactions, or you can say chemical properties of phenol. Before I go on teaching you this, I will be very happy and glad to share that I received more than 50 homeworks done, and there's an improvement in the way you guys are writing the equations and the way you guys are making the benzene ring. And I'm very glad that the work that I'm doing is paying off and it is very satisfying for me. So thanks to all of you and thanks to your parents as well. I hope we will continue these classes as long as we can and as long as we needed them. Today we will discuss the chemical properties of phenol. You can see we have the highlighters now. There's improvement on my side as well. So first of all, the reaction that I want to discuss with you about phenol is how it behaves or how it reacts with sodium hydroxide. Now, sodium hydroxide is an alkali, as you all know. It's a base. It easily decomposes into Na plus and OH minus ions. Phenol, on the other hand, is acidic. It means that phenol will be very easily donating this proton. This proton here, the electron pair between oxygen and hydrogen will stay with oxygen, and it can lose this proton. So when phenol reacts with sodium hydroxide, the acidic nature of phenol, here phenol is acidic by nature, will act as a proton donor, and NaOH as a base will act as a proton acceptor. The H positive ion is also called as proton, if you guys don't know. So the reaction is pretty spontaneous, and this H and this OH, if I can underline for you, or I can highlight for you this OH from the NaOH and this H from the phenol. If they combine, you can obviously guess it's going to be H2O, and the sodium will go and bond with oxygen because it will be negative ion, it will be positive ion. So it's sort of ion exchange reaction here, and it's going to be ONA. This product is a salt, and as you guys know from previous lectures, it's called sodium phenoxide. The formation of sodium phenoxide proves that phenol is an acid, and it's not a very strong acid, not as strong as benzoic acid, but of course more acidic than toluene. Okay, I should rather explain this to you. This is benzene, and if benzene has the carboxylic group, this is called benzoic acid. Now, benzoic acid has two oxygens, so the proton will be very easily removed from benzoic acid as compared to phenol. So the benzoic acid is actually more acidic than phenol. So phenol is less acidic than benzoic acid. In fact, it is less acidic than all carbonyl compounds, carbonyl, which means the carbon double bond oxygen. But phenol is more acidic than alcohols. Alcohols, as compared to phenol, are very, very less acidic. So acidity decreases in this order. As you go this way, acidity decreases. The first reaction which we discussed today about phenol is basically the acidity of phenol. I mean, if the question in the exam comes like, how can you prove that phenol is an acid? Then this equation is a proof that phenol behaves as an acid. The second reaction that I want to discuss is how phenol reacts with zinc. Now you guys know we have discussed already. With zinc, phenol converts to benzene. But zinc, if you can take zinc as lumps, chips, or you can take zinc as dust or powder, or you can take zinc as pieces of metal. Now, as you guys know, the rate of reaction depends on surface area. So if you have a lump or you have a piece of metal, the atoms are inside well packed within, so it provides less surface area for the reaction. However, when you have a powdered form of or finely divided zinc dust, phenol very easily reacts. But once again, phenol is also a solid. So to increase the surface area, we can vaporize phenol. I mean, heat above 43 degrees C, if you remember. 43 degrees C is basically its melting point. So when we heat it, in fact higher than 43, the 150 degrees C maybe, so that the vapors of phenol will pass through the zinc dust, and you will see that liquid will form, the thick oily liquid will form. This oil is basically a benzene. It also contains solid zinc oxide. You can filter them. After filtration, you can separate benzene from it. So it's a much easier reaction to perform as compared to this. If I have to explain this to you, then you can see this is a beaker. All right, and the beaker contains zinc dust. All right, and here we have a sort of connection, and we keep here, let's say, phenol. So if we heat phenol here, vapors will form, and the vapor will mix with the zinc dust, which is solid, and you will see that there will be a liquid formation in this beaker. After filtration, we can separate benzene from zinc oxide. This is the reaction, explains how easily phenol can convert to benzene. However, benzene will take few steps. It will take few steps to convert into phenol, which we have discussed yesterday in the preparation of the phenol. The third reaction that I want to discuss with you is with hydrogen gas. How phenol reacts with hydrogen gas. Now, when any organic compound reacts with hydrogen, it's called hydrogenation. So how can we hydrogenate phenol? Normally, phenol is more reactive than benzene due to the ring activator group, hydroxy OH. Phenol is much reactive as compared to benzene. Still, if the hydrogen gas is in a molecular form, so you can pump hydrogen gas into phenol, or you can vaporize or make liquid phenol, and then you can pump hydrogen gas so it bubbles out at some high temperature. So if you add some nickel dust or finely divided powder of nickel, it will also help the hydrogen gas to convert from molecular to the atomic form. So we need a catalyst nickel, and we need to heat it at 150 degrees C, just below the boiling point of phenol. The hydrogen will add, and you will get all three pi bonds will break. The benzene ring will lose its aromatic character, and this way phenol will convert into cyclohexanol. So it's alcohol. I can make this a little more clear for you if I, instead of making a ring, I show you exclusively three bonds. Okay, so this is benzene, a double, single, double, single, double bond. this phenol has to be in a vapor form, in liquid form. A hydrogen gas will be pumped through, and the nickel catalyst will help hydrogen gas H2 molecular to convert into atomic form, because hydrogen absorbs in nickel surface pretty much well. So they will attack on these pi bonds, and this pi bond will break, and there will be two hydrogen added here. And there will be an attack on, let's say, this pi bond. This pi bond will break, and the 2H will add here, one here, one here. And at this pi bond, if you can see, so all pi bond will convert into single bonds, and you will have this one structure, if you can see. This is the this is hexanone. This is called cyclohexane, in fact. So if cyclohexane has a OH, it should be called cyclohexanol. If still it's not clear to you, I can make it one more time for you. Like the benzene ring is a 6-membered ring. There are 6 carbon atoms. There is OH. So double, single, double bond. So here there's no H. There's 1, 2, 3. So 1H. You guys know carbon valency is 4. 1H and H and H. There's no H. So when you add 3 hydrogen atoms, what is going to happen? If it attacks here, so this will be CH2, CH2. And here, this will be CH2, CH2. And same will apply on this case. This will be addition reaction. The addition reaction will occur at an extreme condition. Of course, this is the condition for it. It will not take place if a phenol in a beaker present in room temperature and it comes in contact with hydrogen, then it will not convert to cyclohexanol. So this will only occur if you have this special arrangement for this reaction. So now these H's will come here, so you become CH, CH2, 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 and CH2, and CH2. This remains CH because there's no H here, one has attacked. And this compound is cyclohexane. With the OH, it is cyclohexanol. So phenol can convert into cyclohexanol by following this procedure. I repeat, phenol solid, we put it into a beaker just like this, and we heat it just under the boiling point of phenol, liquid phenol. We pump hydrogen gas from here. We can add nickel dust inside, so the hydrogen gas coming in molecular can absorb into the nickel surface and come out as atomic hydrogen and react with phenol. This will be nascent hydrogen, atomic hydrogen. So atomic hydrogen will obviously be more reactive, and these pi bonds are going to suffer from the hydrogen gas. And in this reaction, this is called dearomatization. If you can understand this term, dearomatization, it means that the aromatic character of benzene ring is lost. So we can say, we call what? Dearomatization. Those reactions in which the benzene ring loses its aromatic character, which means loses the single double bond setup of hydrogen of the benzene ring. These are the reactions in which the benzene ring loses its aromatic character. So I hope you understand these 3 reactions. First, with the sodium hydroxide, it behaves as an acid, and this is the order of acidity. With zinc dust, it can easily convert into phenol. The process is very simple. In fact, this is one of the method of preparation of the benzene, and also a famous reaction for the annual examination. This as well, hydrogen is added under some conditions. I explained the conditions to you. I hope you got this reaction as well, and there is no confusion in this case. Now, I will move towards the next reaction. Next reaction is, my friends, basically with bromine. So the 4th reaction is with bromine. Now, I repeat for you, if you guys have not seen bromine, bromine is basically a fuming liquid, dark brown fuming liquid. And it is concentrated, so it doesn't react with phenol, not just phenol, but with anything. So if you want a reaction which involves bromine, you have to basically put bromine in water, make a dilute solution of bromine in water. This is called bromine water. Normally, we call it bromine water, basically. So when phenol reacts with bromine in the bromine water, again, due to the reactive nature of phenol, the bromine is substituted in place of hydrogen. So since OH is a ring activator, it will promote benzene, this ring, to react further more and pretty easily. So there are 3 atoms of bromine which basically substitute in the ring in place of hydrogen. So you can make it like this: bromine and bromine and bromine. Now some students make it like this. That's not right. Or this, no. Whenever there is attachment on this carbon, it is always shown in this orientation. Now can you guess the name? Right? If you can guess the name for me. Yep. 1, 2, 3, 4, 5, 6. 2, 4, 6 tribromophenols. The 3 hydrogens here will bond with the other bromine atoms and form 3HBr. Now this is a spontaneous reaction. Phenol reacts with bromine water spontaneously. If we do this reaction with just benzene, benzene will not react with bromine unless you have a Lewis acid catalyst. And even if with the Lewis acid catalyst, it will not make a 2,4,6 product. It will make just 1 bromo benzene like that, or 1 chlorobenzene. You can see that. Bromine is more reactive in this case. Now, this is the 4th reaction. This is important. The chemical difference between phenol and toluene. Now, toluene is also, I can make it here for you. Toluene is also a benzene derivative. It has like this. It's called toluene methylbenzene. Methylbenzene has the other name, toluene. I want to share this with you as well. If there are 2 methyl groups, it's called xylene. Now this is CH3 and this is CH3. This is called O-xylene. If this CH3, the second one is here, which call it P-xylene, that's right. There's no M-xylene because CH3 is not a meta-directing group. Now, when toluene reacts with the same reaction, it will make 1 bromotoluene. It will not make 2,4,6 tribromotoluene. It shows that phenol is more acidic than toluene, or comparatively more reactive than toluene. Toluene is also a very famous derivative of benzene, just like phenol. The 5th reaction, which I'm going to discuss with you, is with the nitric acid. How phenol reacts with nitric acid, HNO3. There are 2 ways to write this, HNO3 or HONO2. In the organic chemistry, we mostly use the HONO2 form because it's much easier to express and much easier to understand how reaction is moving. Now this reaction, just like most reactions of nitric acid, depends on temperature. Now nitric acid reacts faster at high temperature and it reacts slower at low temperature. So if the nitric acid is more or less reactive, the products also change accordingly. Now I will just make the products and you will understand the difference. So this is the phenol, cyclohexane, now it's benzene, and now it's phenol. and this is HONO2, nitric acid. I hope you get it, right? So when this reaction occurs at a room temperature, let's say 25 degrees C, this is normal room temperature, where we taking a dilute nitric acid to react with phenol. What happens basically that since phenol is a ortho-para director, that's why we have two products. This is basically electrophilic substitution reaction, where the nitro group is our electrophile and it will replace the hydrogens. So you can see this one. Now can you guess the name? O-nitrophenol. No, O for ortho. Yeah, you can say 2-nitrophenol as well. But beside this, you also can see another product, which is OH, and here. Now this is called P-nitrophenol. If you know what is para-nitrophenol. Now the two products, we have taken two molecules here, two hydrogens. So the H and OH will obviously, for H from here and this OH will make H2O, and another, so there will be two H2O as well. So you can see that when phenol reacts with nitric acid dilute at room temperature, you get two products, the O-nitrophenol and the P-nitrophenol. Here, if you had taken phenol and you had again nitric acid, but at slightly higher temperature, if you heat it above the room temperature, the higher the better, unless the phenol boils. Okay, in that case you have an interesting product, and it is already discussed plenty of times before today. Yeah, NO2 here, NO2 here, and NO2 here. So do you know what is this called? Yep, 2,4,6 trinitrophenol. You're right. And what else it is called? Yes, picric acid. It is acidic, it is poisonous, it is used to make explosive bombs, ointments to kill the germs. So this is how we can convert phenol into picric acid or 2,4,6 trinitrophenol very easily. But I'm forgetting here, 3 nitro groups they have attacked, so you have also 3H2O. I'm sorry I put the name here. Now here, taking the advantage of this topic, I will also tell you about TNT. If you know TNT, this is this, my friend over here, I want to show you here, if you can pay attention. This is benzene. This is of course toluene. Now this product is called TNT. Now can you tell me what is TNT? TNT, trinitrotoluene. TNT is directly used as explosive in bombs and making bullets. TNT is also called NOS, used in cars to explode their airbags, and this is trinitrotoluene. TNT is a very common name and famous name. This is trinitrophenol. These are two very active products to be used in explosives. So I hope you understood very clearly in quite a detail here with nitric acid how phenol reacts. The next one is with the sulfuric acid. Yep, how can we not mention about sulfuric acid? Now, the reaction with nitric acid is called nitration. Everybody knows about it. That's how we nitrate phenol. What is the reaction with sulfuric acid called? Yes, sulfonation. And it's also a very interesting reaction. Keep in mind, these two are each other's isomers. You can say these ones are position isomers. And the similar thing happens with sulfuric acid as well, but there's a difference between how sulfuric acid behaves with sulfuric acid, much more reactive than nitric acid. The again, temperature, room temperature, high temperature, same thing, but at the products are quite interesting, and let me tell you. Okay, in the first case, we need, of course, phenol to start with, and sulfuric acid is H2SO4. Now, this is mostly written in the organic chemistry as HOSO3H. So the HO, you can guess, make water with the hydrogen being replaced from here. So HOSO3H. Still, this is H2SO4. If you go room temperature, 15 to 20 degrees Celsius, okay, you get orthopara products, just like in the nitric acid. So we make a benzene ring, and we phenol and SO3H, because this is an electrophile. Guys, remember, these are electrophilic substitution reactions. And the second product is para. There is no meta because OH is not a meta directing group. OH is a para directing group. And the release of two water molecules because of the two hydrogens replaced from the phenol. Of course, we needed two phenol and two sulfuric acid. This is ortho product, and this is the para product. With the room temperature sulfuric acid, a reaction gives you major ortho product. Yes, we can call it, this is major and this is minor. It means that they both form together. The reaction has a mixture of products. But let's say if 90% of the product is the ortho one, the 10% product is the para one. This happens in this at the room temperature. When phenol react with the sulfuric acid at room temperature, you get major ortho product and minor para, which means if it contains a 90% ortho product, it will be 10% the para product. If you go, let's say, at high temperature, for example, we take phenol and we make it react with similar sulfuric acid. This is technically same. It is going to be same. If you go on high temperatures, then obviously the product will slightly change. Let's say 100 degrees Celsius. You once again get similar two isomers, the ortho, right, and the para. But this time, difference is you have a major ratio of the para product. This is major, which means 90% of the product is the para one. And minor, the 10% product is the ortho one. Why this happens, what is the reason, or what is the cause, I will explain to you. Basically, at a high temperature, the electronic orientation in the benzene ring is very much delocalized. Electrons are moving around a lot as compared to this. In this case, electrons are mostly with this primary carbon where the OH is attached. So at low temperature, less molecular vibrations, electronic delocalization, causing majority product to be ortho. At high temperature, much localization, electron moving all the way everywhere. So the electrophilic groups will attack on the para product. So this is the last reaction of the phenol, and I'm sure you have understood the lecture. These are the reactions of phenol. First with sodium hydroxide, I discussed with you the same. Then we have with zinc, then how it behaves with the hydrogen gas and what are the necessary conditions, and then we have how it behaves with the bromine and how reaction of phenol with bromine are different as compared to toluene and what are the products, some extra information about toluenes and xylenes, and then last but not the least with nitric acid, giving you ortho para products together 50-50 at room temperature and both at higher temperature. In sulfuric acid, the nature of reaction is slightly changed. So I hope you understood this lecture, and it was a good lecture for you today once again. Now I will end my lecture with with a few things which I need to explain here. We are not doing these lectures for any publicity purpose. We're not even trying to show our names or anything. But the main point is we want to facilitate our students so that when they are at their homes, at their houses, they keep their minds engaged and the study process continue. And we are welcome to help anybody else who seek help or who want help in this case. One more thing, the students are sending me their homeworks on the WhatsApp, which is very good. I check them and I tell them their mistakes, and things are getting better for them as well. This is my number. If anyone else, regardless of the fact that they are studying in our college or not, they can seek help from me and show me if they want to do the work. Because doing the work at home, it kind of it is enforcement that you do. Otherwise, this lecture is no use unless you just do the work and you share with the teacher and you get the comment from the teacher and you get the motivation that you need here. So I'm very glad, and you can send me anytime. Anybody, you do your work, you finish your work, just send it to me. Don't wait for the 9 a.m. or 9 p.m. or 10 p.m. time, because what happened last night, there were so many homeworks coming at 9, like my phone was buzzing. So I couldn't even respond to all the students in time. And so I would just say anytime, if you will send me anytime, and if don't wait for my response immediately, just send and then do your work. I will check the work, and I check every single work and I respond back. I'm very glad that the students are sharing their work, because in the classroom you have student-teacher hesitation and you're afraid of me because I'm also your principal, so it makes the distancing, and you not easy to share with me, but you can share here. Okay, I will do the correction. It will help you. We will end the lecture, but last and the most important thing is about the online tests. The issue with our country is that we cannot ensure 100% transparency of the online test. We are talking with the people to make us the software, but again, if you have to answer the questions in your home, you will definitely not, not everyone, but absolute transparency is impossible. So for now, unless we get to that, I would give you a written test. You will send me the homework once it is done, and the written test basically is of phenol. Okay, preparation, properties, and uses of phenol. You can just learn this all. You might have learned it already. You can make 3 to 4 pages test copy at your home from your old rough copies or your younger brother's copy. You can tear some extra pages and give this test in front of your parent. Give your copy in book to your mother or your father. And then once you're done with the test, you can show it to your parent. They can check it. They can write their name or sign underneath, and then you show me on WhatsApp that you gave this test to your parent. All right? So I will be very happy if you finish this today and also finish the test today, so I can see your fair work and test copy side by side. I will be very glad if the parents give their input. I don't want to involve the parents at all because they are busy. They have to take care of lots of other stuff. But just a signature, just a copy, just a look on the work, and just compare your child's test sheet with the work that they have done, and just write their comments, and then the children will send me. This way it will be good engagement, good bonding between the teachers, parents, and the students. Thank you so much. It was great to talk with you. Today's lecture went 10 minutes extra. I'm sorry for that. I'll see you tomorrow. And I also want the test, and you can send me anytime you want. Thank you so much. Goodbye. Have good health.